Okay, guys, as promised, we're going to go over conception and prenatal development today. So just remember, it's important to understand the prenatal development, to understand conditions and developmental delays that occur because we may work with babies as early as 22 weeks of gestation. Delivered prematurely and their development resembles a fetus entering third trimester. Also helps us understand the behavior patterns of preemies and can help us understand why certain conditions occur. We're going to have three prenatal periods. One is the first one is the germinal pre-embryonic period, which is single cell produced by union of sperm and ovum. That's also called a zygote at approximately 2 weeks. In zygote, half chromosomes are from the father and half are from the mother. Zygotes divide and multiply numbers of cells, and these begin to differentiate to create different structures. It takes approximately 2 weeks after conception for unicellular zygote to implant in uterus. This is called the germinal period. Then we have the embryonic period, which is developing human from conception, approximately 2 weeks through 8 post-conception, and all body structures are formed and an embryo is formed. And then you have the fetal period, which is during the human or developing human from weeks 9 post-conception until birth. Major body structures are maturing, and this is known as a fetus. So during the germinal stage is the fertilization, also known as conception. This was that first video we showed in class. This is a really good time to pause this and kind of watch that again. It's the process when the sperm and the ovum join into a zygote. And then sperm determines sex of the zygote. So an X chromosome is female and a Y chromosome is male. So if you're seeing XX chromosome, it's a female. If you're seeing an XY chromosome, it's a male. So I'm gonna pause and let you guys watch that video. Okay, then you have the germinal period. Begins with fertilized ovum, also known as a zygote, approximately 2 weeks. Development actually starts 12 to 24 hours after sperm penetrates the egg. It travels through fallopian tubes to the uterus, divides and forms additional cells on its journey, and contains 46 chromosomes. Then you have pluripotent stem cells rapidly divide. Remember, we talked about pluripotent stem cells in class. They can become any type of cell the body needs. After 2 weeks, these cells become specific. So the germinal period is especially interesting when it's involving stem cell research. Then you have the zygotes become blastocytes. A blastocyte contains inner cell mass, ICM, which becomes the embryo. So that contains about 60 cells. It's fluid filled, and the ICM will become an embryo. Then you have the trophoblast, which is the outer layer of the cells, helps the blastocyte implant on the uterine wall. Implantation mostly common around 8 to 9 days, but it depends on the ovulation aspect. Becomes the placenta, and like once again, implantation occurs between 6 to 12 days after conception. Week 2, ICM develops into a flat 2-layer embryonic disc as well. So then we have the problematic implantation. So we have placenta breva, which is placenta attaches on the lower part of the uterus, covering opening of cervix, results in bleeding and premature separation of placenta, often on bed rest and needs cesarean to protect mother and baby. Then you have the placenta accreta, which placenta attaches too tightly to the uterine wall, cannot detach after birth. If it did, it would cause massive hemorrhaging for the mother. Then you have the placenta percurta, which the placenta grows to the wall of the uterus, potentially to nearby organs. And then you have an ectopic pregnancy. So that's the implantation of a blastocyte outside of the uterus, mostly fallopian, but rarely in ovary, stomach, and cervix. So a tubal rupture or other serious complications can occur, even threatening the mother's life in this stage. So now we're going to talk about twins. So we have monozygomatic, which are identical twins, which originate from the single egg sperm combination and share the same genetic background. So they often look alike and share many of the same characteristics. Then you have monozygotic twins that are always the same gender with very few, very rare exceptions. Then you have the mono twins, which have the same amniotic sac, same placenta. 1% of these are identical twins and can be very dangerous, often preterm and small. Then you have the mono-di twins, which have different amniotic sacs but the same placenta. Then we have the dizygotic or multizygotic, which are fraternal twins. So this is when separate eggs fertilized by separate sperm that share the same period of gestation. So it has its own unique combination of genes. Um, and then you have your di twins, which are each have their own amniotic sac and two placentas. With their own unique combination of genes, they have the same genetic connection as any other sibling, but share a womb during gestation. So dizygotic twins can be boys, girls, or a combination of both. Okay, so then we have embryonic development, which happens in the third week and ends in the eighth week of development. So remember, a zygote is 2 full weeks, and then the embryo starts on that third week. All tissues and organs are formed, and human characteristics begin to emerge. This is a period of rapid cell proliferation and differentiation. By the end of the stage, the embryo resembles a human in appearance. So it develops cephalic, the head to caudal, tail, and then the embryonic disc divides into 3 layers of the cells. Embryo is highly susceptible to teratogens, which is any agent that causes production of physical defects in developing the embryo. These may alter the process during embryonic period. Type of anomalies is determined by gestational timing of exposure, the dosage, the amount, and for how long the duration, and what kind of teratogen it is. Embryonic period is very sensitive to teratogens. We're going to talk more about those in the next couple slides. So we have our medications, our maternal infections, and maternal disorders, as well as toxins. So remember, any agent that causes the production of physical defects in the developing embryo is known as a teratogen. So some common ones for medication would be tetracycline, which can cause stained teeth and enamel hypoplasia. Then you have isotetranine, which can cause pregnancy loss, hydrocephalus, CNS defects, small and absent thymus, small outer ear or no outer ear at all, and a conjunctional heart defects. Then you have cocaine utilization, which can cause pregnancy loss, placenta abruption, and growth dysfunction, as well as microcephaly. Then you have maternal infections, which you have toxoplasmosis, which can cause hydrocephalus, blindness, and mental dysfunction. You have syphilis that can cause abnormal teeth and bone deformities, as well as mental dysfunctions. Then you have herpes, which can cause pregnancy loss, growth dysfunction, eye abnormalities. Then we're going to talk about maternal disorders, which are diabetes mellitus is a common one, which can cause heart defects, neural tube defects, limb defects, holoprocephaly, which is HOLOPROSENCEPHALY, which is where the front part of the brain doesn't develop. Then you have toxins, which are including cigarette smoking and chronic alcoholism. With cigarettes, it can cause pregnancy loss as well as low birth weight. And then chronic alcoholism can cause growth and developmental dysfunction, microcephaly, and then craniofacial dysmorphism. A very common disease is also fetal alcohol syndrome with kids that are born. This was the article about the opioid crisis. If you guys want to have another listen, take time. It's about a 4-minute little listen bit. But every 15 minutes, a baby is born suffering from opioid withdrawal, which this was a statistic that happened, I believe, in the early 2020s. So I need to double check and see if there's any other updated statistics. But you can see in the United States in 2014 is more than a 5-fold increase since 2004 when they were last checked, which is kind of crazy to think about. So then you have the embryonic period, which is week 3. We're looking to learn about the disc develops with 3 germ layers. So the 3 layers of the cells are the endoderm, which is the inner layer, the mesoderm, which is the middle layer, and the ectoderm, which is the outer layer. So the endoderm gives rise to the digestive system, several glands, and parts of the respiratory system. So some excrete system are the kidneys. Then your mesoderm gives rise to muscles, bone, cartilage, cardiovascular, reproductive, circular systems, excretory systems, dermis, skeleton, and connective tissues. Um, and then you have your ectoderm, which gives rise to skin, teeth, nervous system, and other structures. So your excretory system can include things like your kidneys because they're excreting different things out of your body. So then you have your nervous structure development in the embryonic period, which happens between days 20 and 24. So you have your notochord, which is from the mesoderm. So remember that middle area. It's a cord around for which the vertebral column will eventually form. Then you have your neural plate from the ectoderm, which is the outer layer. It's the basis of the central nervous system and forms neural groove, which will form the neural tube. And then your neural tube thickens to form the spinal cord. Incomplete closures and would become neural tube deficits. So an example of this would be spina bifida. And there's believed to be a role of folic acid involved with spina bifida. I'm going to pause right here to give you guys a chance to watch this really quick video of the early fetal development. Okay, so then we have this, which is that silent video that I showed you. So if you guys would prefer, you guys can go ahead and cue that video up now, or we can follow along with this diagram. The video shows a good representation of this diagram, and it's more interactive. I'm gonna give you a second to pull up the video if you want to. So I'm gonna hopefully use my cursor, and hopefully you guys can see. So the line forms down the center of the embryonic disc called the primitive streak. So primitive streak, it's gonna form this right here. The cells will accumulate to the primitive streak and it elongates and moves inwards, infolds, and forms the primitive groove. So it will make the primitive groove. The primitive streak will disappear around the beginning of the 4th week. And then in your mesoderm, the cells will migrate between the ectoderm and the endoderm to form the notochord, which is the vertebral column, and that forms around this. Then the ectoderm will form the neural plate, broadens and extends along the notochord. Indentation forms called the neural groove. Edges are the neural folds, and then eventually come together to form the neural tube. The neural tube separates from the ectoderm. Another group of the ectodermal cells migrate to become the neural crest. The neural crest will then separate into 2 areas of the cells, one on each side of the midline, to become peripheral and autonomic nervous systems. The expansion leads to become flexed instead of flat. The endoderm gives way to the digestive, urinary, respiratory structures at cephalic end and caudal end. This will still be a flat, but will begin to curl and have human resemblance at the end of the 3rd week. It clearly defines cephalic, caudal, dorsal, and ventral surfaces. So then you have your embryonic period, weeks 5 through 8. So this is where cartilage, bones, muscles are formed, ossification begins in upper body, your faces start to develop, and your vertebrae and ribs start to come in. Limbs begin to elongate, fingers webbed, embryo is still about 3 to 5 centimeters long. You have a well-defined large head, ears, eyes, eyelid folds, sex organs begin to form, and at this stage, recognizable human form. So this period is characterized by major differentiation and growth of many organs. Into this stage, you're going to see a more recognizable human. So this is about your 8-week ultrasound right here. So we have the fetal period, which is 9th week through birth. This is growth, structure, and psychological refinements of systems and structures. So this is a period of rapid growth. First length comes and then the weight comes. Organ differentiation continues. Teratogens are less damaging, so no widespread or lethal damage. May cause placenta malfunction or growth restrictions, and defects will be localized. So I'm going to pause this right here so you guys can take a look at this next video. It's from the same website as the previous one. It's about 1.5 minutes or so. It's a good representation of this period. So then you have weeks 17 through 20, where the lango or the fine hair that appears on the embryo itself. Then you have the vernix seosa, which is white and greasy paste. Um, this protects from injury to the skin, and the fat provides insulation. So brown fat specifically allows the fetus to maintain its own body heat. Adipose tissue and brown fat accumulate weeks 17 through 20, and lung maturation and all elements present but have non-functional. So this is about your 20-week ultrasound, what that would look like. So you have weeks 21 through 25, an increased probability of survival after week 23 with intensive life support. About week 22 is surfactants produced, which enhances survival. So the surfactants in the lungs, high mortality rate through week 26 due to immature respiratory and CNS. They can hear as early as 24 to 28 weeks old, not survivable before 21 weeks unless they're 500 grams. Many early age premature babies will have secondary disabilities, and extremely low birth weight is under 1,000 grams. So we're going to take a minute or watch this video. So click that link below. All these videos are also posted on Blackboard in a separate folder too, so you can have them queued up while you're watching. So weeks 26 through 29, so we have VLBW, or very low birth weight, which is under 1,500 grams. Neuroregulation of breathing by week 30. Fetal viability could live outside the uterus, starts happening during this period. Thermal regulation still not developed, and if born now, need help with this. And there's a risk of neonatal complications after week 28 that are low. So again, there's another video at the end of this one, another about minute and a half or so. So during the fetal period, weeks 30 through 34, we have accelerated weight gain. Probability of surviving without problems start to increase and get higher and higher, and may still need some thermal support throughout. So your fetal period of weeks 35 to 38, the average weight of birth is about 3.4 kilograms or 7.5 pounds. Fat accumulates 14 grams a day, and we're now prepared for feeding, respiration, elimination, and once separated from the actual placenta. So when is a typical term date due date? Does anyone know? So it's typically between 39 and 40 weeks. Then we're going to talk about mental function. So it can be difficult to assess. Instead, we have to look at fetal behavior. So standardized test shows to predict abnormal neuro outcome based on prenatal behavior. So we have the KINET, which is the Kerjack antenatal neurodevelopmental test. We have the GMA, the gross motor assessment, and the TEMP, the test of infant motor performance that OTRs can assess fetal. So assessing behavior, arousal through behavioral states. So a behavioral state is a period of coordinated activity punctuated by periods of rest. So we have 6 behavioral states in neonate newborn. So the 6 are deep sleep, light sleep, drowsy, quiet alert, active alert, and crying. Again, they're deep sleep, light sleep, drowsy, quiet alert, active alert, and crying. These gives us insight into brain function. They also have one's level of arousal determines response to environment. As a fetus approaches term, rest and activity is more defined. Typically, a newborn after 35 weeks has an identifiable sleep and wake cycle from deep sleep to crying. So some critical periods. There's limited time in which development event can occur and most receptive to learning that behavior. Periods when at great risk for congenital anomalies or developmental disabilities, during periods of major structural formation, and there's also some on your book. So if you see figure 8.2 on pages 157. So we also have some other influences on fetal development. So we have chromosomal abnormalities. Does anyone know how many chromosomes we typically have? So a typical chromosomal count is 46. So with an extra or missing chromosome, that can cause what's known as Down syndrome or trisomy 21. So this creates physical changes. So a flat facial profile, slant to the eyes. They're stocky and large tongue. They're at risk for mitral retrogulation, which is MR, which is a valve or heart deformity, heart defects, and leukemia. Midlife, many develop Alzheimer's too. And there's also other genetic disorders known as like Tourette syndrome, Huntington's disease, and Fragile X. Here's another video that's a really good video to kind of watch and check out. Okay. That is the end of our PowerPoint. What I want you guys to do is review these PowerPoints before our class on Thursday. Come with any questions or anything that you need clarified for this PowerPoint, as well as the WHO and the ICF. We're going to try and work through as many questions as we can at the beginning of the class. So that way you guys have time to study for your test on Tuesday. And then at the end of the class, or towards the end of the class, we're going to do like a group little project to help us with some of these terms. Hope you guys have a good rest of your night, and I will see you guys hopefully in class on Tuesday. If not, I'll see you guys at group study tomorrow.